is the phenomenon such, is it similar to like a polar shift where there may be some parts of the world that are currently cold that might become real warm as the rest of the world gets cold? Or is this going to be like pole to pole and just east to west, the whole thing?
Well, if you get a real ice age rather than the little ice age I've just described, a real one, like the one that ended 11,400 years ago, then over most of the northern hemisphere, which is where most of the land is, the southern hemisphere is nearly all water, so it doesn't count, but for most of the northern hemisphere, there would have been very large amounts of ice over what is now Europe, Russia, Mongolia, China, America. Most of that would have been covered in ice to a depth sometimes of several miles. So really a lot of ice worldwide, and that ice would reflect the sunlight back into space, making it harder for the sun to warm up the planet anyway, which is why these ice ages, we think, last so long. And what seems to make them come and go is there are three separate variabilities in the way that the Earth goes round the sun. First of all, there's what's called the eccentricity of the Earth's orbit. In other words, it doesn't go round in a perfect circle. It goes round in an ellipse with the sun at one of its foci. If you remember that the ellipse has two foci, whereas the circle has a single center. And the sun is at one focus, of an ellipse, which is what the Earth describes as it goes round the sun. And the eccentricity of the ellipse, which is the difference between the length of its major and minor axis, varies over a time scale of sort of tens of thousands or hundreds of thousands of years. That's one of the three effects. Then there is what's called the obliquity of the Earth's axis, which is the angle that it makes with the plane of its orbit. In other words, if you imagine its orbit as a kind of huge disk with the sun in the middle of it, then the angle of the Earth's axis in relation to that disk around which it goes varies again over a period of sort of tens of thousands of years. And that too influences where the ice comes on the planet, where the sun comes in and hits the ground, and that can cause big changes in temperature. And the third of these cycles, which are known as the Milankovitch cycles, over the person who first wrote them up. They were originally discovered, interestingly, by an autodidact, a self-taught university janitor called Kroll, who instead of cleaning the library of the university, sat and read books of astrophysics and worked out these three cycles all by himself. He didn't get the credit, though. But anyway, the third of these cycles is what's called the libration of the Earth's axis, which means it wobbles every 26,000 years. At the moment, it's pointing towards the pole star, but in 13,000 years' time, as it was 13,000 years ago, it will point to the constellation of Vega, a different place in the sky altogether. Once again, this introduces changes. Now, because you've got these three separate major cycles operating over very long time scales. I mean, you wouldn't notice any difference between, say, 100 years ago and today as a result of these cycles. But what we think happens is that with certain combinations of these three cycles, you suddenly get conditions which are right to shift the Earth either from an interglacial warm period like today into an ice age, or from an ice age back into an interglacial warm period. That's what we think, but the interesting thing is that actually nobody really knows why the Earth comes into and goes out of these big ice ages.
What about technology? And I'm a great believer that there are things beyond our purview. There are things that simply we can't do anything about. But what about technology? Do we have some way, for example, of using the satellites in orbit or launching satellites that could perhaps magnify, like a magnifying glass, the heat from the sun to bathe the Earth in constant or greater heat than it otherwise would have, and thereby mitigate an oncoming ice age? Or am I just talking?
Well, what you're talking of is known by scientists these days as geoengineering, and to science fiction fans as terraforming, where you do engineering on so large a scale that you hope you can affect the climate of the planet. Now, frankly, all such measures as have been proposed so far would be wickedly expensive, extremely problematical, and most unlikely to succeed. At the moment, I think it is still in the realm more of science fiction than of reality. I mean, looking at it the other way, if you wanted to cool the Earth, could you put up vast, very thinly beaten out sheets of aluminum in space, which would act as giant umbrellas shading the Earth's tropics from the sun and cooling everything down a bit. And these too have been fanciful ideas put forward by corporations eager to make absolutely trillions out of being asked to do this by politicians panicked by the scientists who are telling us that global warming is going to be a problem. But for the moment, I think it's probably fair to say that all such proposals are really beyond our means, and most of them beyond our technological ability as well. What would I think be a better use of the money is putting up satellites like the one that NASA put up a couple of years ago, and it's the last NASA satellite to crash, rather a sad business, because that satellite was going to give us very accurate measurements of two particularly vital observations whose relation to one another gives you the answer to how much of a problem we might have with the climate. That satellite would have given us the answer by now, possibly. And that is, you measure the changes in the surface temperature of the Earth over periods when it's clearly changed by enough in one direction or another to get you clear of what is called statistical noise, which are random effects of temperature going up and down a little bit. And then you measure in those periods corresponding changes in how much of the flow of solar radiation that has come in from outside is getting back out again and not being trapped down here by the greenhouse gases. It's that relationship between what is called the radiative flux at the top of the atmosphere and the changes in surface temperature that determines how much warming you're actually going to get, not only from CO2 but from any other greenhouse gas. And we do not yet have really accurate measures of that relationship. And it's the most important thing we now need to measure. And Professor Richard Lindzen of MIT, who's a great expert on this field, has done some research into this. He very carefully analyzed the data over the last 20 years from the satellites we do have up there, each of which has, to some extent, problems with its data collection. But nevertheless, he was able to form a view to which he has adhered, despite a rather stinging attack on his paper of last year on this by some ClimateGate emailers. He adheres to the view that the amount of warming we are going to get if you, say, double the CO2 in the atmosphere is really only likely to be somewhere between a quarter and a fifth of what the UN's climate panel and all the supporters and true believers in the new reason of global warming would lead us to expect. He thinks we're going to get much, much less warming than they expect because of these measurements that he's taken using the satellite data. Now, the question really is he right? And there are a number of different ways in which you could approach this. I mean, one that I did, which was very simple, was you go back 60 years, and that's about the first, 1950 is about the first year when we had an accurate reading of how much greenhouse gases there were in the atmosphere. You can compare the concentrations in 1950 with the concentrations, say, in 2010. And you can work out, using the UN's own simplified formulae for how much warming each greenhouse gas should cause, how much warming its methods would have predicted over that 60-year period. And as best I can do the sum, they have overstated the warming by at least double. Take away that exaggeration, and you take away the climate problem.
And that's to be expected when the reporters themselves have some kind of vested interest in arguing one way or another. Before we run out of time, I do have two very, very quick questions for you. Is there anyone who's dared to offer a prediction on how much of the human population would survive a real ice age, if any?
It would be a pretty dreadful event. I think you could expect 5/6 of the human population to be wiped out if an ice age came suddenly enough. It's all a question of how profound it was and how sudden it was. But it would be a catastrophic event. It would be far more damaging than an equivalent movement of temperatures in the other direction.
Is there any way for people to plan for such an event? Is there anywhere safe from such an event? And how do you recommend people respond to the forewarnings of a coming ice age?
Well, the first thing is don't panic, because all these forewarnings are not based on any really scientific evidence. We don't know what causes the ice ages. We don't know exactly what the conditions are that bring them about. I suspect these are conditions that almost appear by accident, but heavily influenced by these changes over the long term in the Milankovitch cycles of the Earth's orbit. So I would say, don't worry about it. Of course, anywhere near the equator is likely to be less affected by ice than anywhere else. But if you go back 750 million years, and you're probably too young to remember that, but at that time, there was ice even 2 miles thick at the equator. And the interesting thing about that was at the same time, the atmosphere was 30% CO2 compared with 0.04% today and no ice at the equator. So it does look as though the warming effect of CO2 may not, after all, be anything like as big as the UN's climate panel would like to pretend.
And we are out of time. My guest has been Lord Christopher Walter Monckton, the 3rd Viscount Monckton of Brenchley. It has been an honor and it has been a privilege to have you back on the show, and we thank you so much for your expertise and for your ongoing efforts on behalf of truth.
Well, a real joy and a pleasure. I hope it hasn't all been too technical for you, but you did ask some quite detailed questions, and I sometimes think it's worth giving the answers in reasonable detail. And of course, if any of your...
We're out. We're out. Thanks so much. God bless.
Okay. All the very best.